What did you learn about machine learning, about engineering, about life, about yourself as one human being from working with Elon Musk?
I think the most I've learned is about how to sort of run organizations efficiently and how to create efficient organizations and how to fight entropy in an organization.
So human engineering in the fight against entropy.
Yeah. I think Elon is a very efficient warrior in the fight against entropy in organizations.
What does entropy in an organization look like exactly?
It's process, it's process and
inefficiencies in the form of meetings and that kind of stuff.
Yeah, meetings. He hates meetings. He keeps telling people to skip meetings if they're not useful. Yeah. He basically runs the world's biggest startups, I would say. Tesla, SpaceX are the world's biggest startups. Tesla actually is multiple startups. I think it's better to look at it that way. And so I think he's extremely good at that. And he has a very good intuition for streamlining processes, making everything efficient. Best part is no part, simplifying, focusing, and just kind of removing barriers, moving very quickly, making big moves. All of this is very startup-y sort of seeming things, but at scale.
So strong drive to simplify. Yeah. From your perspective, I mean, that also probably applies to just designing systems in machine learning and otherwise.
Yeah.
Like simplify.
Yes.
What do you think is the secret to maintaining the startup culture in a company that grows? Is there, can you introspect that?
I do think he needs someone in a powerful position with a big hammer, like Elon, who's like the cheerleader for that idea and ruthlessly pursues it. If no one has a big enough hammer, everything turns into committees, democracy within the company, process, talking to stakeholders, decision-making, just everything just crumbles.
Yeah.
If you have a big person who's also really smart and has a big hammer, things move quickly.
Anyway, what do you think is the value of setting seemingly impossible goals? So like our initial intuition, which seems like something that you have taken on, that Elon espouses, that where the initial intuition of the community might say this is very difficult, and then you take it on anyway with a crazy deadline. You just from a human engineering perspective, have you seen the value of that?
I wouldn't say that setting impossible goals exactly is a good idea, but I think setting very ambitious goals is a good idea. I think there's what I call sublinear scaling of difficulty, which means that 10x problems are not 10x hard. Usually 10x harder problem is like 2 or 3x harder to execute on. Because if you want to actually if you want to improve a system by 10%, it costs some amount of work. And if you want to 10x improve the system, it doesn't cost 100x amount of work. And it's because you fundamentally change the approach. And if you start with that constraint, then some approaches are obviously dumb and not going to work. And it forces you to reevaluate. And I think it's a very interesting way of approaching problem solving.
But it requires a weird kind of thinking. It's just going back to your PhD days. It's like, how do you think which ideas in the machine learning community are solvable?
Mm-hmm. Yes.
It requires, what is that? I mean, there's the cliche of first principles thinking, but it requires to basically ignore what the community is saying. Because doesn't a community in science usually draw lines of what is and isn't possible?
Right.
And it's very hard to break out of that without going crazy.
Yeah. I mean, I think a good example here is, the deep learning revolution in some sense, because you could be in computer vision at that time during the deep learning sort of revolution of 2012 and so on. You could be improving a computer vision stack by 10%, or you can just be saying, actually, all of this is useless. And how do I do 10x better computer vision? Well, it's not probably by tuning a hog feature detector. I need a different approach. I need something that is scalable, going back to Richard Sutton's and understanding sort of the philosophy of the bitter lesson, and then being actually, I need a much more scalable system, like a neural network, that in principle works, and then having some deep believers that can actually execute on that mission and make it work. So that's the 10x solution.
What do you think is the timeline to solve the problem of autonomous driving? That's still in part an open question.
Yeah, I think the tough thing with timelines of self-driving, obviously, is that no one has created self-driving.
Yeah.
So it's not like, what do you think is a timeline to build this bridge? Well, we've built 1 million bridges before. Here's how long that takes. no one has built autonomy. It's not obvious. Some parts turned out to be much easier than others. So it's really hard to forecast. You do your best based on trend lines and so on, and based on intuition. But that's why fundamentally it's just really hard to forecast this. No one has.
So even still, like being inside of it, it's hard to do.
Yes, some things turn out to be much harder, and some things turn out to be much easier.
Do you try to avoid making forecasts? Because like Elon doesn't avoid them, right? And heads of car companies in the past have not avoided it either. Ford and other places have made predictions that we're going to solve level 4 driving by like 2020, 2021, whatever. And now they all kind of backtrack on that prediction. Are you, as an AI person, do you for yourself privately make predictions, or do they get in the way of like your actual ability to think about a thing?
Yeah, I would say like what's easy to say is that this problem is tractable. And that's an easy prediction to make. It's tractable. So it's going to work. Yes, it's just really hard. Some things turn out to be harder, and some things turn out to be easier. But it definitely feels tractable, and it feels like at least the team at Tesla, which is what I saw internally, is definitely on track to that.
How do you form a strong representation that allows you to make a prediction about tractability? So, like, you're the leader of a lot of humans. You have to kind of say this is actually possible. Like, how do you build up that intuition? It doesn't have to be even driving. It could be other tasks. It could be, what difficult tasks did you work on in your life? I mean, classification, achieving certain, just on ImageNet, certain level of superhuman level performance.
Yeah, expert intuition. It's just intuition. It's belief.
So just like thinking about it long enough, like studying, looking at sample data, like you said, driving. My intuition is really flawed on this. Like, I don't have a good intuition about tractability. It could be it could be anything. It could be solvable. Like, the driving task could be simplified into something quite trivial. Like, the solution to the problem would be quite trivial. And at scale, more and more cars driving perfectly might make the problem much easier. Like the more cars you have driving, and like people learn how to drive not correctly, but in a way that's more optimal for a heterogeneous system of autonomous and semi-autonomous and manually driven cars. That could change stuff. Then again, also I've spent a ridiculous number of hours just staring at pedestrians crossing streets and thinking about humans. And it feels like the way we use our eye contact, it sends really strong signals, and there's certain quirks and edge cases of behavior. And of course, a lot of the fatalities that happen have to do with drunk driving, and both on the pedestrian side and the driver's side. So there's that problem of driving at night and all that kind of. So I wonder, it's like the space of possible solution to autonomous driving includes so many human factor issues that it's almost impossible to predict. There could be super clean, nice solutions. Yeah,
I would say definitely, like, to use a game analogy, there's some fog of war, but you definitely also see the frontier of improvement, and you can measure historically how much you've made progress. And I think, for example, at least what I've seen in roughly 5 years at Tesla, when I joined, it barely kept lane on the highway. I think going up from Palo Alto to SF was like 3 or 4 interventions. Anytime the road would do anything geometrically or turn too much, it would just like not work. And so going from that to like a pretty competent system in 5 years, and seeing what happens also under the hood, and what the scale at which the team is operating now with respect to data and compute and everything else, is just massive progress. So
it's you're climbing a mountain and it's fog, but you're making a lot of progress.
It's fog. You're making progress, and you see what the next directions are, and you're looking at some of the remaining challenges, and they're not like they're not perturbing you, and they're not changing your philosophy, and you're not contorting yourself. You're like, actually, these are the things that we still need to do.
Yeah, the fundamental components of solving the problem seem to be there, from the data engine to the compute to the compute on the car to the compute for the training, all that kind of stuff. So you've done, over the years you've been at Tesla, you've done a lot of amazing breakthrough ideas in engineering, all of it, from the data engine to the human side, all of it. Can you speak to why you chose to leave Tesla?
Basically, as I described, I think over time, during those 5 years, I've kind of gotten myself into a little bit of a managerial position. Most of my days were, meetings and growing the organization and making decisions about sort of high-level strategic decisions about the team and what it should be working on and so on. And it's kind of like a corporate executive role, and I can do it. I think I'm okay at it, but it's not like fundamentally what I enjoy. And so I think when I joined, there was no computer vision team because Tesla was just going from the transition of using Mobileye, a third-party vendor for all of its computer vision, to having to build its computer vision system. So when I showed up, there were 2 people training deep neural networks, and they were training them at a computer at their legs, like down.
They're doing some kind of basic classification task.
Yeah, and so I kind of like grew that into what I think is a fairly respectable deep learning team, a massive compute cluster, a very good data annotation organization, and I was very happy with where that was. It became quite autonomous. And so I kind of stepped away, and I'm very excited to do much more technical things again. Yeah. And kind of like refocus on AGI.
What was that soul searching like? Because you took a little time off and think like how many mushrooms did you take? No, I'm just kidding. I mean, what was going through your mind? The human lifetime is finite.
Yeah.
You did a few incredible things. You're one of the best teachers of AI in the world. You're one of the best, and I don't mean that, I mean that in the best possible way. You're one of the best tinkerers in the AI world, meaning like understanding the fundamentals of how something works by building it from scratch and playing with the basic intuitions. It's like Einstein, Feynman were all really good at this kind of stuff. Like small example of a thing to play with it, to try to understand it. So that, and obviously now with Tesla, you help build a team of machine learning like engineers and a system that actually accomplishes something in the real world. So given all that, like what was the soul searching like?
Well, it was hard because obviously I love the company a lot, and I love Elon, I love Tesla. I want so it was hard to leave. I love the team basically. But yeah, I think I would be potentially like interested in revisiting it, maybe coming back at some point, working in Optimus, working in AGI at Tesla. I think Tesla is going to do incredible things. It's basically like, it's a massive, large-scale robotics kind of company with a ton of in-house talent for doing really incredible things. Yeah. And I think human robots are going to be amazing. I think autonomous transportation is going to be amazing. All this is happening at Tesla. So I think it's just a really amazing organization. So being part of it and helping it along, I think was basically I enjoyed that a lot. Yeah, it was basically difficult for those reasons because I love the company. But, I'm happy to potentially at some point come back for Act 2. Mm-hmm. But I felt like at this stage, I built the team, it felt autonomous, and I became a manager, and I wanted to do a lot more technical stuff. I wanted to learn stuff. I wanted to teach stuff. And I just kind of felt like it was a good time for a change of pace a little bit.
You mentioned humanoid robots. So what do you think about Optimus, about Tesla Bot? Do you think we'll have robots in the factory and in the home in 10, 20, 30, 40, 50 years?
Yeah. I think it's a very hard project. I think it's going to take a while. But who else is going to build humanoid robots at scale? Yeah. And I think it is a very good form factor to go after because, like I mentioned, the world is designed for humanoid form factor. These things would be able to operate our machines. They would be able to sit down in chairs, potentially even drive cars. Basically, the world is designed for humans. That's the form factor you want to invest into and make work over time. I think there's another school of thought, which is, okay, pick a problem and design a robot to it. But actually designing a robot and getting a whole data engine and everything behind it to work is actually an incredibly hard problem. So it makes sense to go after general interfaces that, they are not perfect for any one given task, but they actually have the generality of just with a prompt with English able to do something across. And so I think it makes a lot of sense to go after a general interface in the physical world. And I think it's a very difficult project. I think it's going to take time. But I see no other company that can execute on that vision. I think it's going to be amazing. Basically physical labor. Like if you think transportation is a large market, try physical labor. It's like insane.
Well, but it's not just physical labor. To me, the thing that's also exciting is the social robotics. So the relationship we'll have on different levels with those robots. Yeah. That's why I was really excited to see Optimus. Like people have criticized me for the excitement, but I've worked with a lot of research labs that do humanoid-legged robots, Boston Dynamics, Unitree, there's a lot of companies that do legged robots, but that's the elegance of the movement is a tiny, tiny part of the big picture. So integrating the two big exciting things to me about Tesla doing humanoid or any legged robots is clearly integrating it into the data engine.
Mm-hmm.
So the data engine aspect, so the actual intelligence for the perception and the control and the planning and all that kind of stuff, integrating into this huge the fleet that you mentioned, right? And then speaking of fleet, the second thing is the mass manufacture. Just knowing culturally driving towards a simple robot that's cheap to produce at scale. And doing that well, having experience to do that well, that changes everything. That's why that's a very different culture and style than Boston Dynamics, who, by the way, those robots are just the way they move. It's like it'll be a very long time before Tesla can achieve the smoothness of movement. But that's not what it's about. It's about the entirety of the system, like we talked about, the data engine and the fleet. And that's super exciting. Even the initial sort of models. But that too was really surprising, that in a few months you can get a prototype.
And the reason that happened very quickly is, as you alluded to, there's a ton of copy-paste from what's happening on the autopilot. A lot. The amount of expertise that came out of the woodworks at Tesla for building the human robot was incredible to see. Basically, Elon said at one point, we're doing this. And then next day, basically, all these CAD models started to appear. And people talking about the supply chain and manufacturing. And people showed up with screwdrivers and everything the other day and started to put together the body. And I was like, whoa, all these people exist at Tesla. And fundamentally, building a car is actually not that different from building a robot. The same, and that is true, not just for the hardware pieces. And also, let's not forget hardware, not just for a demo, but manufacturing of that hardware at scale is a whole different thing. But for software as well, basically this robot currently thinks it's a car.
It's going to have a midlife crisis at some point.
It thinks it's a car. Some of the earlier demos, actually, we were talking about potentially doing them outside in the parking lot, because that's where all of the computer vision was working out of the box.
That's funny.
Instead of inside. But all of the operating system, everything just copy pastes. Computer vision mostly copy pastes. I mean, you have to retrain the neural nets, but the approach and everything, and data engine and offline trackers and the way we go about the occupancy tracker and so on, everything copy pastes. You just need to retrain the neural nets. And then the planning control, of course, has to change quite a bit. But there's a ton of copy paste from what's happening at Tesla. And so if you were to go with the goal of okay, let's build 1 million human robots, and you're not Tesla, that's a lot to ask. If you're Tesla, it's actually it's not that crazy.
And then the follow-up question is then how difficult, just like with driving, how difficult is the manipulation task, such that it can have an impact at scale? I think, depending on the context, the really nice thing about robotics is that unless you're doing manufacturing and that kind of stuff, is there's more room for error. Driving is so safety critical, and so that and also time critical. A robot is allowed to move slower, which is nice.
Yes. I think it's going to take a long time, but the way you want to structure the development is you need to say, okay, it's going to take a long time. How can I set up the product development roadmap so that I'm making revenue along the way? I'm not setting myself up for a 0-1 loss function where it doesn't work until it works. You don't want to be in that position. You want to make it useful almost immediately, and then you want to slowly deploy it and
at scale,
at scale. And you want to set up your data engine, your improvement loops, the telemetry, the evaluation, the harness, and everything. And you want to improve the product over time incrementally, and you're making revenue along the way. That's extremely important, because otherwise you cannot build these large undertakings just don't make sense economically. And also from the point of view of the team working on it, they need the dopamine along the way. They're not just going to make a promise about this being useful. This is going to change the world in 10 years when it works. This is not where you want to be. You want to be in a place like I think Autopilot is today, where it's offering increased safety and convenience of driving today. People pay for it, people like it, people purchase it. And then you also have the greater mission that you're working towards.
Mm-hmm. And you see that, so the dopamine for the team, that was a source of happiness.
Yes, 100%. You're deploying this, people like it, people drive it, people pay for it, they care about it. There's all these YouTube videos. Your grandma drives it. She gives you feedback. People like it. People engage with it. You engage with it. Huge.